Okay, the distributive property. Algebraically, it looks like this. We have some number outside of the parentheses and some operations going on here, either addition or subtraction, and we multiply whatever's on the outside to the terms inside the parentheses. So we end up with A times B plus A times C. And the same thing happens if we have subtraction. Doesn't matter. We take whatever's on the outside and we multiply it to what's on the inside of the parentheses. So this is just the algebraic example of the distributive property. Now, the distributive property can be applied in several ways, and that's what I'm going to show you is different applications of the distributive property. Okay, so in this first example, we want to use the distributive property to simplify the expression, and this expression is 24 times 98. So what we can do is break this down into look something like this, a number on the outside, and we're going to make 98 into a sum, so or a difference. So in this case, let's make it a difference. Let's go 100 take away 2. So we can say, because 100 take away 2 is 98, so now let's apply the distributive property. So applying the distributive property is multiply 24 times 100. So 24 times 100 is 2400. And the distributive property tells us we got to multiply the 24 times this 2. And 24 times 2 is 48. And so now we can go ahead and subtract 24 minus 48, which I'll do over here. 2400 minus 48. Borrow from here, make that a 3. This is a 9, and this is 10. So 10 take away 8 is 2. 9 take away 4 is 5. 3 take away nothing is 3. 2 take away nothing is 2. So we get 2,352. Okay, so let's try a second example using the distributive property in this way. So we have 13 times 103. Of course, you can just come over here and multiply straight out, or we can use the distributive property, which I want to show you. So what we're going to do is take the 13 on the outside and make the 103 a sum. So I want to use 100 plus 3 because I'm thinking ahead. So here we go ahead and distribute. This is a 0 right here. We distribute, meaning we're going to multiply 13 times 100, which is just 1300. And then multiply 13 times the 3, which is 39. And now we can add that together. And this is a simple addition of 1,339. So using the distributive property to simplify this expression kind of makes our multiplication a little easier. You know, your choice. Okay, so now here's another situation where we can use the distributive property, and that's when we're just simplifying expressions. So in this first expression, we have 2 times the quantity 3 minus 7t, or 3 minus 7 times t. So the distributive property tells us to take the number and multiply it to each of the terms inside. So I'm going to multiply the 2 times the 3, which gives me 6, and also multiply the 2 times the 7t. 2 times 7t is 14t. Now these are not like terms since 6 does not have a t. This is the extent, or as far as we need to go right here. So we simplified it. So here we can have a second example, and in this example we have parentheses and a number outside, but it's on the right hand side. That doesn't mean that we change the rules of the distributive property. It still means we got to multiply this number on the outside to the terms inside. So I'm going to multiply this negative 3 times this 0.4x. So negative 3 times 0.4x is 1.2x, and it is negative. Now I have to multiply this negative 3 times this 2.2. So 3 times 2.2 is 6.6, and that is negative. So we got to make sure we are distributing the whole sign. Since this is a negative 3, I'm multiplying a negative 3 times these numbers. So that's why they became negative. I could simplify this a little more since we have an addition or adding a negative number. Anytime you're adding a negative number, it is the same as just subtracting a positive. So we could have negative 1.2x minus 6.2. So this is simplified completely right here. Because once again, these are not like terms, so this is as far as we can go. Okay, so here's another expression where we can use the distributive property. It's not as clear as the other ones, because one of the mistakes is they look at this 4 and they say, oh, it's outside the parentheses. No, it is actually separated by the subtraction sign. And the subtraction sign is what we're going to actually distribute. And in reality, that subtraction out here by itself, we can look at that as an implied 1. So what we're really doing is distributing or multiplying by a negative 1 to everything inside of the parentheses. So for example, I'm going to write it all the way out literally. So we're going to do negative 1 times 2x gives me a negative 2x, and then negative 1 times, we bring this plus sign, negative 1 times a positive 1 gives me negative 1. Okay, so I brought that all, I distributed this negative 1. I didn't distribute the 4. Okay, and now we can simplify this a little bit since we have some like terms. We have a 4 and a negative 1, which are like terms because they both are just regular constant numbers. So we can put those together. So I'm going to take this 4 and I'm going to combine it with this plus negative 4. So that's going to give me a 3, because 4 plus negative 1 is 3. Bring down that minus 2x. And now these are not like terms, so I will stop right there. Okay, for our last example, it looks similar to the one we just finished doing, except for this time we actually have a number right next to the parentheses. Instead of just the negative sign, I have a minus 2/3. So we're going to distribute the minus 2/3 or the negative 2/3. We're going to distribute it as though that sign goes with it. So we're going to go ahead and multiply. So we bring the 4 down because we're not distributing that. Multiply negative 2/3 times the 6m. So that's going to give me a negative 4m. And now I'm going to bring down the minus sign because that's right here and multiply this minus 2/3 or negative 2/3 times the 9. So I'm going to end up with a negative 6. Now, if you don't know how to multiply these together, what I did was I took the 6 and put a 1 under it and multiplied across. 2 times 6 is 12, 3 times 1 is 1. So that was 12 over 3, sorry. And 12 over 3 is 4. Same thing with this 9. If I put a 1 under it, 2 times 9 is 18. 3 times 1 is 3. 18 divided by 3 is 6. Okay, so just a little quick reminder for those who are like, how the heck did I get right there? Okay, so that's just a little quick review on that. So now back to this problem right here. We are on 4 minus 4m take away a negative 6. So again, we do have some like terms with the constants. So the 4 and this minus 6 right here, minus a negative 6. You could see that as, or simplify this down to be 4. Subtracting a negative 6 is the same thing as adding a positive 6. So 4 plus 6 is 10 minus the 4m. Again, these are not like terms, so this is where we would stop our problem. All right, so that's using the distributive property.